So hello everyone, hope you're learning well. So this video will be about using transfer learning, and we'll use a pre-trained VGG-16 network, and we'll try to really code it out and see how we can use our own custom data and use the concept of transfer learning on a pre-trained VGG-16 network. Okay, so let's get started with it. So first of all, let's see what actually transfer learning is. So if you go by uh, definition, I got it from online. It says the application of skills, knowledge, and or attitudes that were learned in one situation to another learning situation. So basically, if you see, we have been doing transfer learning throughout our whole life, since from the time we are born, so till now, in everywhere we use transfer learning. So if you we actually don't notice it, but if you would have rode bicycle, and if you have learned bicycle, then it will not take much time for you to take on the motorbike. So because the things or whatever the techniques which you have learned while riding bicycle on the road, oh, I'm sorry for that. So whatever techniques you have learned in riding bicycle, the same techniques, some of the basic techniques that can be applied in riding motorbike also. And same in case of if you play any instrument, like if you play a guitar, then you learn the notes in that and how you play the scales, the chords. And if you take up ukulele or maybe violin, so it is a different instrument, but the basic knowledge of how to play the notes and all, so that knowledge you can transfer it from the knowledge you learned during playing guitar to over this instrument. And up to many things, even in studies, in mathematics, or even in cooking, we always apply transfer learning, knowingly or unknowingly. So this is the concept, and how can we apply it in our machine learning model. So suppose, for take example, that we train a network to recognize horses and cats. So it is a classification network which classifies horses and cats. Now this, suppose you want to train a network which also classifies the dog. So what you can do, I'm sorry for this again. So what you can do is, you take this network and then you use this network and then train a dog classifier over it. So whatever it has learned during this, it will use that knowledge, and then it will learn over the dog also, and finally we get a classifier which classify cat, horses, and dogs. Okay, so let's see how we'll do it. So yeah, before that, so transfer learning will be the next driver of ML success, and Renji said it in NIPS 2016, and even I got this graph from his talk. So it also says how the transfer learning is growing over time, and it is used in lot of problems in industry, because nobody want to train the entire network from scratch. Instead, you use a pre-trained network and just fine-tune it. So this one I got it from Stanford notes. So it says that transfer learning, you can use it in three ways: either as a fixed feature extractor, or we simply fine-tune the ConvNet, or we use a pre-trained model. So let's see what it means. So this is a pre-trained, this is a simple VGG-16 network. So it will have 16 layers of 16 weight layers. So 16 layers in which weights can be trained, convolution. At the end, 1000 means it's 1000 class. It has been trained on ImageNet challenge. So one is, you use a pre-trained network. So whatever this network is trained, you use those network as your starting point, and those weights as your starting weights, and then you train your your classifier on it, or your data set on it. Another is using VGG-16 as fixed feature extractor. So since you know the convolution network is a feature extractor as well as a classifier, so here we usually assume that the layer just before the classifier layer is a feature layer. So we get this feature for each of the images. It's a 4096 dimensional feature, and instead of using their classifier, you can use your own classifier like SVM or neural network with a different number of classes, not 1000. So you can use it as a feature extractor. And another is fine tuning. So what do you mean by fine tuning is, we use the pre-trained network, but we fine tune some of the layers, which means we train some of the layers. So for example, so if you what I'll do in fine tuning is, up to some of the layers I will just freeze this layer, the weights of the network, and then from here I will train it. So I'll actually fine tune it for my problem. So you can see and this fine tuning you can do like up to any layer you want to go up, you can do it. So there is some rules for that, we'll look into that. So what the logic behind is, in deep learning it's a hierarchical based feature extractor. So the initial few layers, they will extract some kind of simple features. So if you take example of faces, the initial layer will learn some edges, and then if you go deeper layer, so it will learn some of the face part like nose, lips, and then finally the object. Similarly, if you take a car, the initial, oh, I'm sorry for this again, it's disturbing me. And if you, for example, if you take a car, then it will learn the edges, then it will learn the car object parts, and then some more like high dimension object parts like honeycomb structure, and then it will learn the car. So we'll look into it, how to and how many layer to freeze it depending on what is your data set. Okay. So yeah, so this is also a lecture note from Stanford. So they are saying if we have small data set, and if your data set is kind of, what to say, small and similar to the ImageNet dataset or on which your network has been trained, then it's simply you use it as a feature extractor. And instead of taking 1000, if you have suppose 4 or 10 classes, you just swap it with FC10 or FC20 or FC100, how many number of classes you have. And another is, if you have a medium sized data set or large data set, then you can fine tune the network. So what is that, you freeze the layer up to here, maybe, which extract your basic features, and then you retrain the network from here. So you freeze the weights up to here and then you retrain it. So this is by fine tuning. So depending on the data set, you can decide. If you have very large, then you can train more number of layers. If you don't, and also if your data set is very similar, then obviously the feature extracted will be similar up to a number of layers, and except for the final layer where the features will be different, so you can just train the final layer. Okay, so I will be demonstrating with a code how I'll do it. So in my case, I will train it as a classifier, because I have a very small data set, and I have four classes of what to say, objects. So you see, up to here I will freeze the network, and the last layer I will add my FC4, and then I'll train this part. And for demonstration, I will also show you how to do fine tuning. So I will freeze up to here. Sorry for this, man. I'll freeze up to here, and then instead of using their 4096 4096, I can add my stuff. And you can freeze up to anywhere, and you can like add your own layers, or retrain that existing 4096, or you can add your layer. Like I'll show you. I added 128 120 and then 4, and then add it. Okay, great. So this is how the VGG-16 model is defined in your Keras 2. So it's given in some kind of blocks. It's the same thing, and we'll look into it. So I'm using Keras 2.0.7 and TensorFlow 1.3.0, and data is which I have used in my previous video. I have 808 samples and 202 samples in each classes. I have 4 cats, dogs, horses, and horse riders. Okay, so let's go to the coding. Let's see how we can code it away. Yeah, before that, from where you can download this pre-trained models. So it is now available in Keras. You just type a deep learning model Keras, and you can go here. Yeah, okay, so you download this. You just clone it or download it somewhere. I have already downloaded it, and this will have all the networks. It will have ResNet 50, VGG-16, and Inception, Exception. So in this video we'll see VGG-16, in the next video we'll see ResNet. So if you open VGG-16 network, you will see, so it's defined in this way, and the weights are given with top and no top. So I'll explain what that means. So, and yeah, so the network is like this. So it will have conv2d, conv2d max pooling, like this one actually. Yeah, so if you see, So it's if you see, it's the convolution block 1, convolution block 2, convolution block 3, 4, 5, and then the fully connected classifier. So this is what is given in the code also. So yeah, you can see this. So let's work it out, and so you can just for testing it out, it's given here also, but I'll just use it here. Yeah, so let me open a new console, and so let's import all the libraries. So let me do that. So it says we are importing VGG-16 from the VGG-16 script, and we are calling the VGG-16 model with include top equal to true. So what this include top means, if you see here also, so it says where is it? Yeah, so if you include top means it will get the weights of this also, so it will get this final if you, let's see it from here. Yeah, so if you include top means it will include this fully connected classifiers, and if you don't include top, then it will take from the beginning up to this convolution block 5. It will not take the fully connected layers. So that's what means with including top. Okay, so we have downloaded it, and when you call this, so it will load the model, and if you have the weights, then it will load it, and if you don't have it, then it will download it. So it will be showing something like this, and this will be in your Keras directory. So you go to your home directory, and it will be in your .keras folder. Inside model, you will have all the weights downloaded there. Okay, it will do it a one time, and once it's downloaded, it will load it. Okay, so I have already got it, and now let me get an image. So it's an elephant, and it will load it. So the VGG-16, it has that it take input size of 224 by 224, and we not worry. So we can use Keras pre-processing image, and it will load it. Then we convert it into array, and we expand the dimension to get it into the shape of number of image and then image size. And then we apply pre-processing, which is actually some mean subtraction, and you can see the input shape. It will be this shape, and now we predict what's the result. So yeah, and we can decode the predictions as per ImageNet classes. So it says it's Tusker 43%, African elephant 42%. So let's see what it is actually, the image. Yeah, so it is. So you can try it out in any image, and it will give you some result. And you can see the model summary, and you can see the layer. It's it's a block 5, and then flatten, and then fully connected one 4096, 4096, and finally 1000. Okay, great. So yeah, and another thing is you can use it as a feature extractor. So in case of that, if you just want, up to here, just up to the block 5, and then flatten and use it whatever, then you can include top equal to false, or in the next I'll show you, when we are training it on a custom data, that we can simply load the entire network including the top, and then access any of the layer. But you can also get your model with top equal to false, and in that case, if you see the model summary, then you see it's only up to block 5. There is no flattened layer, the dense 4096, 4096, and 1000. Okay, and in this case, if you load anything and you predict it, so your model is only up to here, so you will get the feature as, let's see it. So features will be of this shape: 1, 7, 7, 512. So this will be your features. So as you could have seen it here also. Yeah, so it will be 7, 7, 512. So yeah, that's just the basic. And now let's see how we can train it for our custom data. Okay, so I have written this script for training it on a custom data, and I will give the link below of my GitHub where I'll post this code so you can try it on of your own. Okay, so let's first load all the necessary libraries, and so I'm doing it from scratch so that you can just do it. And I'm using TensorFlow backend, I told you before. Yeah, so now this is the same thing, just this one I just wrote to show you that what actual shape of image will be. It will be 224 224 3, but we need into shape of number of images, this dimension of image. So we need something kind of like this for one image, and if you have 100 image, it should be 100 224 224 3. Okay, now let me load my data set. So my data is here. In this directory I will give this data also in a zip format in my GitHub. So simply let's load it, and I will define a list where I'll store all of this. And basically I am having this data directory list which has the list of all my 4 categories: cats, dogs, horses, human. I will loop over all the list, and inside every list I will loop over all the images, and then I'll append all the images in this image data list. Okay, so let me run this. Actually, if you want to understand like what is happening, how we are loading and training a custom data set on CNN, you can watch my video, it's there. Okay, so now this is the image data list. It's 808 total. Now let's convert it into array. So it will be in the format of 808 1 224 224 3, but we want 808 224 224 3. It should be number of images, number of rows, number of columns, number of channel. So you can just print it here and see it's in this format. We don't want this, so we'll roll the axis and sorry. Now if you print the shape, you will get it something like this. So we don't want 1, so we'll take it off less 0, and now you'll finally get your image of this shape. So number of samples, number of rows, columns, and channel. Great. So now we are done with this, and number of classes I'm having is 4, and now we have to assign labels to each of this. So number of samples is here. Labels, first I will just take as np.once, and then I'll assign label. So first 102 samples are cats, second 102 samples are dogs, and then horses, and then humans. So I'll assign label as 0 1 2 3. Okay, great. So if you see the label, so you can see it now, it will be 0 for 102, and then 1 2 and 3, and so on. Okay, great. So names is here. Yeah, and now I'll convert into one hot encoding. So you'll see how it looks, one hot encoding. I hope you know it. So if you see the capital Y variable here, so now the 1 will be 1 0 0 0 because there are 4 classes, and the 2 will be 0 1 0 0, 3 will be 0 0 1 0, and 4 will be 0 0 0 1. Okay, so this is required because in the neural network output we have 4 nodes. So for each input we should have 4 predictions, and it should be compared with 4 of the labels. So that's why we assign labels in one hot encoding format. Great. Now let's shuffle the data. So it's good practice to shuffle the data, and I am not having an extra data for validation or testing, so I'll split this data. 20% of data I will keep it as a validation set or test set using sklearn function train test split. So now if you see xtrain, there are 646 samples, and xtest 162 samples. Okay, so now since the data set is loaded, now let's load our model. Okay, so first we'll give the input shape. The input shape is 224 224 3. Now we'll call the model, and I'm including the top equal to true. Okay, so I load the model. Now it's loading here. Now let's load the model summary. Great. Now now if you see the model summary, so now we want only up to this 4096, and from here the last layer we don't have 1000 classes, instead we have 4 classes. So we need to get up to here only. So what I'll do is I'll just get the layer number. So I'll take last layer as model dot get layer fc2, which is this. So using this you can get actually any layer number, and from there you can add on your network and you can train it, So I'll get this one, last layer, which will be 4096, and then I will add one layer over it. So how will I add it? So I will add a dense layer of number of classes, in which my case is 4, and it is a softmax activation function. Its name is output, and input to this is the last layer, which is the 4096. Okay, so I'll run this line, and now I'll make my own custom VGG model using this Keras model function API, and its input will be the image input, this one, and its output will be the layer which we defined just now, which is the 4 layer. Which is the layer with 4 classes. So I define my custom VGG model, and now if you see a summary over it, now you see my layer, last layer name has become output, which I just defined, and number of neurons is 4, which is here number of classes. So now it is this model is designed as per your data, and now if I want I can train it. Okay, so I can simply but before training you need to compile the model, and you need to freeze it out, and then you can train it. But one more thing which I wanted to discuss. So okay, let me just train the model, and let me just comment this out. So now your model is of this shape, which I told. I'm not fine-tuning it, I'm just training it as a classifier. So now we have defined fc4. Now we have to freeze these layers. Okay, so let's see how we do that. So first let's compile this custom VGG model. I'm using a loss function as categorical cross entropy, and I'm using the optimizers ada delta and matrices accuracy. You can use anything. Okay, now if you see, just take any layer, so custom VGG model layers 3, and check whether it's trainable or not. So you will see that it's trainable, and even if, when I printed a summary, it says that total parameters this much and trainable parameter this much, non-trainable parameters 0. So now we don't want to train the entire model, we just want to train this last layer. So what will I do is I'll read this loop for layer in custom VGG model dot layer, all the layers except the last layer. So -1 index the last layer. I will make this layer trainable as false. Okay, so let me run this. So this will freeze the model. Okay, and so now if you check custom VGG model, and you see, so it says trainable false. And even if you do the summary, custom VGG model dot summary, then you will see the total parameters this much, and only trainable parameters are 16388, which are the parameters for the last layer, and all the other parameters are freezed, so they won't be trained. So they are just working as a feature extractor, and the last softmax neural network, we are using it as a softmax classifier. So great, so I hope you got the idea, and I will start the training. So let me just train it. I just give a variable in order to see the accuracies and losses using this. So custom VGG model dot fit x train y train, batch size, epochs, and verbosity and validation data. In this it's the data which I splitted it. So if you have another group of data, you can load it like the way I loaded the data, and use them as a validation data and test data. Okay, so let me start the training. It's just for 12 epochs. Let me run it, and the training should start here in my console. Yeah, so it's training on 646 samples and validating on 162 samples. So actually I'll pause so I'll pause my system, because my system is my network is running on CPU, so it will be taking some time, and once the network gets trained, I'll get back. So now my my network has been trained. So I trained it just for 12 epochs, and you can see the validation loss and the accuracy. So let me enlarge this one, and you can see after 12 epochs I'm getting a training accuracy of 100%, a loss of 0.005, a validation loss of 0.646, and a validation accuracy of 83%. So it shows quite good result. So this actually model and this network and this data is just for giving you the concept of how to apply transfer learning for your own data. In practically, your data size need to be a bit larger, and you have to fine tune your network by various trial and error methods. So yeah, and yeah, so this was this part, and then you can check the loss and accuracy here by evaluating on the X test, which is already there. Yeah, and one more thing was this graph I didn't show you. So this is the graph plotted for training loss, and sorry, it's okay. So it's this blue color is the training loss, and okay, let me stop this. Okay, so this blue color is the training loss, and this is the, excuse me for that, sorry again. Yeah, so this is the training loss and this is the validation loss. So validation loss is actually fluctuating. We need to train it for like more epochs, I suppose. And this is the accuracy. So the training accuracy has reached up to 100%, and maybe it's overfitting, I don't know, on the training data maybe. And the validation is around 85%. But that's pretty cool. I just wanted to show you the idea of how to implement it. And now let's run this. And this one is a way to evaluate your model on your test set, and it will show something. And the what do you say, the code for plotting the graph is this one. That's why I use the hist variable. So from that hist variable I can access the history of loss, validation loss, accuracy, validation accuracy, and I can plot it. So actually, if you want to know more about this, you can watch like how to plot this confusion matrix for your data and plotting your accuracy curve and all this. You can check out my previous tutorial on CNN implementation for own data, part 1 and part 2, and the code is here in my GitHub, own data CNN implementation Keras. At the end, when I have trained the network, I have described all this. Better you watch the video and how to plot this curve, and then even to plot the confusion matrix. I suppose it's below somewhere. Yeah, this is the confusion matrix part. Great. And even for this this tutorial, it will be, the codes will be in transfer learning Keras for custom data. It will be transfer learning VGG-16 custom data. Great. So yeah, where is the code? So it's just evaluating it, and we'll see the result. So now this, whatever the model we trained was, we trained it as a classifier. So if you remember at the beginning I said we can, if you have a very small data set, we just train it as a classifier. So I just give a 4 class in the instead of 1000 class, and I train it. Now another way is fine tuning the network. If you have a little bit larger data set, then you can fine tune the network, or you can like add more number of layers, or different number of neurons in the existing layer. Like fine tuning, I will be, instead of 4096, I will add 128 and FC4. So let's implement this network. Okay, so evaluation has been completed. Let's see what's the accuracy here. It will obviously, what is the validity. So the loss is 0.646 and accuracy 83.95%. So cool. Now let's see how we can fine tune the model for more number of layers, to be precise, this model. Okay, so again we just define the input. We call our VGG-16 model with weights equal to true, and if we check the summary, so sorry, so it is this FC1 is 4096,000, which is the VGG-16 network. Now I actually with this you can access any, you can actually get any specific layer in the network by just giving name model.get layer name dot output. So it will give the output of that layer, and from there you can add on your layers. So I'll take this block here, block 5. I'll take this as last layer from the model, and then I'll flatten it because it's a pooling layer. It's in the shape of 7,7,512. I'll flatten this layer, and then I will add a dense layer of 128 neurons, and another dense layer of 128 neurons, and finally the final softmax layer with number of neuron as my number of classes. And then I will define the model with Keras model functional API with image input and output as this, and it's same as the previous. And now if you see the summary, now your networks should look something like this. So we have block full same, flatten same, and FC1 has 128 instead of 4096, 128, and 4 at the end layer. Great. So you can access any layer, and from there you can add on, you can add your convolution, pooling, any sorts of thing. Okay. So again, now we have to freeze the layer which we want to keep the weights. So I just want to train this last 3 layers. So I'll freeze the layer from last up to 3. So -1, -2, -3. I'll make the layer trainable as false. And you can see here the non-trainable, there are 0 parameters, but after this, so there will be this many non-trainable parameters, and only last 3 layers weights will be trained. So once we have defined this layer, we then compile this model, and then we run the training same as before, and it should start training. And once it gets trained, then you can evaluate it, and also you can use it for your test data of model.predict and try out all those sorts of things. And actually it's everything is described in these 2 videos of how to test on the new data set and everything about convolution neural network, so you can have a look at this. So so it has started training, and its accuracy shows 31%. So it will take some time, it will train, but the concept remains same. So I hope you got an idea of how we can use transfer learning for your own dataset on VGG-16 network for this time. One more point I wanted to mention. So even if you have a small dataset, you can build powerful classification model, and you can look into this blog written by the developer of Keras, Frank. Okay. So it's building powerful image classification model using very little data, and you can read this blog how he's using this data augmentation, and then using this same kind of transfer learning bottleneck features, and he's making some powerful model small data. Okay, so you can have a look at this. And so pretty much that's it from this video. So in this video we saw how we can apply transfer learning in Keras for VGG-16 for your own data, and next video will be looking into ResNet 50 network and how we can apply our transfer learning in this model. So I hope you like the video and learn from it. So enjoy and keep learning. Bye.